Yeah, okay. So here's problem 98, where we were asked to find the standard deviation of these 4 values. These are the first 4 students to arrive to a first period class, and that information is important later. So when we find the standard deviation from the definition, we're looking at deviations from the mean. What's the mean of those 4 numbers?
8.
It's 8, right? And then how far is 7 away from 8? 1. How far is 7 away from 8? 1. How far is 9 away from 8? They're all 1 away from the mean, right? In the definition, we squared each of those deviations. 1 squared is 1. Yeah. So we end up with a sum of deviations, sum of squared, and I'm going to write this crazy looking expression. Sum of squared deviations from the mean equals 4, right? It's just 1 squared plus 1 squared plus 1 squared plus 1 squared.
Do you have to write that?
No, you do not. You don't have to write that. I'm just being really detailed about it now. So this is what's called the variance. We find that first. The variance is divided by n minus 1. Do you remember n stands for number of observations? There are 4 observations, so we're dividing by, instead of 4, we're dividing by 3. Okay? Standard deviation is the square root of that, and I need someone to tell me what this is.
1.15.
1.15.
Oh, no, I lied. No, I was right.
1.15 is the standard deviation. Okay? We've found that from its definition. Interpret the value of the standard deviation we obtained in part A. So who would like to practice that? This is part A, this is part B. Brendan, yes.
On average, the amount of sleep per student deviates by 1.15 from the mean.
Awesome. On average.
Wait, we're at 1.15, not 1.1, not 1.
It's okay. Either way.
Okay. So like if I said deviation is 1, that's fine.
I'd say write a little more than that. So 1.2, 1.5 is okay. Okay. Hours, right? Okay, does that help, Haruka? That was one of your questions? Okay, on average, the amount of sleep per person deviates from the mean by 1.15 hours. Okay, the next question, part C, is one that we addressed yesterday in a slightly different context. Do you think it's safe to conclude that the mean amount of sleep for all 30 students in the class is close to 8 hours? Okay, thoughts on this, George?
I think I wrote, it is reasonable to believe that students who slept less are likely to be later than students who slept more, so the mean is most likely less.
Ah, okay, so you've gone so far as to think about some reasons why these first 4 students might not represent all of the 30 students in the class. And you're saying that those who arrive first, and notice that it's a first period statistics class, those who arrive first may have slept longer than the other students in the class. Okay?
The sample size was too small.
Okay, sample size was too small, might be a factor. The bigger factor is the type of individuals that we're collecting.
I said that because it was less than 15% of his class, it's not very accurate.
How do you know about that?
Because it's 4 people over 30.
Okay, it could be accurate, it just might not be precise. Okay, there is a difference. What I mean by that statement is that if we were to take a sample again of 4 people, we might get something wildly different.
Yes.
Wildly different. So there's a lot of variability in that estimate. Okay, it doesn't necessarily mean it's not accurate. Accurate, we'll talk about accuracy and precision later, but accuracy in statistics means that if we take repeated samples, the average of those many samples would be the truth. Okay? Precision means that we get estimates that are close to each other if we repeat the sampling many, many, many times. Okay? Something to add, Brendan?
Nah, never mind, forget it.
Okay.
I don't think I'm right.
Remember what we wrote on the board yesterday. Does the sample represent the population? What's the population we're interested in?
In the first period class.
30 students in the first period class. The sample is the first 4 people to arrive to the class.
So yes, it does.
It
Is
does
that
not.
supposed to be random? Like, it could just be people who live closer to the school, like.
Okay, so random's a key word, right? The way to find a representative sample is to choose a random sample. We talked about it, we'll talk about it more in chapter 4, but just know, R for random, R for representative, okay? Is the first 4 people who arrived to class a random sample? No, it didn't give everyone in the class an opportunity to be part of that sample. His sampling method gave preference to the first 4 people who arrived to class, okay? So the only way to take a random sample would be to give everyone a number, 1 through 30, give each of those numbers the same chance of being selected, okay? So this method, the first 4 people to arrive in class may not be representative of all 30 people. Okay? We don't have to say they are not representative of all 30 people. We just have to say they may not be representative of all 30 people, okay? If there's a possibility that they're not representative, then it's not a good sample. There may be cases where the first 4 people to arrive to class provide a reasonable representation of the entire population, but we can't be sure. There could always be something unknown to us that makes those people different in some way from the entire population. So to account for that possibility, we always randomize. We good?
Yes, ma'am.
Great, random representative. Now I'm gonna stop our video.